All right, so I'm going to go ahead and go through these questions to the practice test that I gave you in class on Thursday in preparation for your test on Tuesday. So this first one here says a sound intensity I varies inversely with the square of the distance R from the speaker. So here we're looking at this idea of varying inversely, right? So remember something like y varies inversely with x if you have y equals k over x, right? So for some constant of variation k, that's what it means for y to inversely vary with x. So now what we want to do is apply this idea here. So here we're going to think of the intensity I as y, and our variable x here is going to be r, right? But here, what does it say? That it varies inversely with the square of the distance r from the speaker. So if I'm trying to write this, this would say that I is equal to our constant of variation k divided by, in this case, we're thinking this as r right here, but it says it's going to vary inversely with the square, so this is going to be r squared down here. So that's how we're going to write the function relating the intensity I and the distance r using k as the constant of variation. So now we have the general form here where I is equal to k over r squared. Now we want to figure out what k is by using this next part here. So it says when the distance from the speaker is 5 meters, the intensity is 32. What is the constant of variation? So we know what I is here. We just want to solve for k. So let's do that first. So let's say k is equal to I times r squared, right? All I did was multiply both sides of the equation by r squared to solve for k. Now what I want to do is use the intensity that I was given in this question here and the corresponding radius. So this would be k is equal to, the intensity was 32 and the radius r was 5. So this would be times 5 squared. So now we have 32 times 5 squared. That's just 32 times 25, which is 800. So now we know what our constant of variation k is. It's 800. So if we wanted to rewrite what this equation back up here is, then we could say something like this, that I of r, right? Because here we know what k is now. This is just going to be a function of r. So I of r is going to be 800 divided by r squared. And we're going to use this formula here in part C. So it says, what is the intensity when the distance is 8 meters? So all I'm going to do is plug in this 8 into this formula here. So this would be I of 8. So this is equal to 800 then divided by 8 squared. So this is just 800 over 64. And this is equal to, whenever you do the division, not 65, 64 right here. My apologies. So 800 divided by 64. And when we do this division, this gives us 12.5 units. So whatever the units for the intensity are, it didn't specify any units. So here, up here, it just says the intensity is 32 units. So that's what we're going to use for the units of the intensity. It's just units. So that's how we solve the first one there. We're looking at varying inversely. Now, the next one looks at how do I vary in directly. So this second one here, it says, according to the table below, does P vary directly with Q? Why or why not? So we had a little bit of discussion in class of like how this one was a little bit different than what we were used to seeing. So we can think of this as we have P is equal to Y and then Q is equal to X. So if we go back to the definition of directly varying, we said that y directly varies with x if y can be written as k times x. So here, if we want to think of it this way, then we're just going to replace y with p. So this would say that p is equal to k times q. So all we need to see is if it follows this form here. And the one way we can check that is by looking at the ratios p over q, each of these ratios p divided by q, and seeing if these equal the same constant of variation k. So let's do that for each of these. If I look at this first pair over here, p divided by q is 1/5, which this is 0.20 if we go to convert it to decimals. This one here, 2 over 9, is equal to, if we're going to decimals, 0.22. So here we already see that these first two aren't even the same whenever we look at the ratio p over q. So that means the constant of variation is not the same. So no, p does not vary directly with q because k is not constant. Because in order for this to vary directly, this k here, this constant of variation must remain constant. And here, just from these first two pairs, we can see that it is not. So therefore, p does not vary directly with q. So now let's go on to this next page here. So this was the true and false questions, and you could expect to see something like this on the test as well. So it says for the following questions, write T for true and F for false, just like you would do on any true and false type of portion. So let's look at this first part. So it says for any real number b greater than 0 and m greater than or equal to 2, b to the 1 over m equals the mth root of b. So this is just the definition. So this is true. So this next one here says that f of x equals 3 to the x is a power function. So a power function looks like you have some variable x to some power n. So that's what it looks like for a power function, whatever variable we're looking at here to some power. So this one here does not look like that. This is an exponential function. So here, this is actually false. So let's look at the next one here. So this says n to the z is a power function for any z. So here, this looks like this form, right? X to the n. Here, n is our variable, z is the corresponding exponent of the power. So this one is actually true. Let's look at part D. For any integer k greater than or equal to 3 and for b greater than 0, b to the k over k is equal to b. So this is actually true. So let's think of why. So here, k over k is just 1, right? So this is saying b to the 1 power is just b, and that's true. This one says, if asked to simplify the square root of 49, you would say it does not exist. So this is actually false because the square root of 49 can be simplified. It's actually 7. So this is false. Part F. If asked to simplify 60 or 36 to the minus 1/2, you would say it does not exist. Again, this is false. So if we tried to simplify 36 to the minus 1/2, this can be written as the following. 36 to the minus 1/2 is equal to, if we want to flip this, it's 1 over 36 to the half, right? That's how we get rid of the negative exponent. And 36 to the half is just the square root of 36, so this is 1 over 6. So this was false. Now let's look at Part G. So it says for any real numbers r and s greater than 0, r plus s squared is equal to r squared plus s squared. So this is actually false in general. The reason being that whenever I FOIL out r plus s, there should be a plus 2rs in here, and there's not. So here this is false. This one here, for any real number r and s greater than 0, r times s to the fourth power is r to the fourth times s to the fourth. That's true. Here, for any non-zero real number, c to the 0 is 0. This is false. This was one of the properties we talked about a while back in one of the sections, that if we have c to the 0 power, this is actually 1, or anything to the 0 power is 1. So this is false. Part J. For any non-zero real number x and y, x to the fifth over y to the fifth is equal to x to the y, x over y to the fifth power. This is true. If the ratio q over p is constant, then q varies directly with p. That is true. That is just the definition. So if we looked back at the first question, here it said p varies directly with q. All it did was flip-flop this. So here, the volume of a sphere V equals 4/3 pi r cubed is an example where volume varies inversely with the cube of its radius. This is false. This is actually where it varies directly with the cube of its radius. If it varied inversely, this r cubed would be down in the denominator here, but it's not. So this is actually a direct variation. And the last part of this question, the statement G of G inverse of Z equals Z is always true for Z in the domain and range of G. This is true. So let's think of it this way. What does an inverse function do? It goes and does the opposite operation of G. It goes backwards. So whenever I do my function G and then I undo that function G at the input Z, it should just give me back the output Z. And that's what it does. So let's move on to number 4 now. So it says solve 7r cubed minus 42 equals 33. So we're going to start by adding 42 to both sides first. So if I add 42 to both sides, then this gives me that 7r cubed is equal to 133 plus 42 is 175. And when I divide both sides by 7 here, I get r cubed is equal to 25. And then the last step here, to solve for r, I need to take the cube root of both sides. So r would be the cubed root of 25. And that is my exact answer because it says for r exactly. So here we wanted the exact expression for r, not any approximation, the exact answer, which is the cubed root of 25. And this cannot be simplified any more than it is here. All right, so let's move on to number 5. So it says using the formula here, we want to solve for the variable k. So this is just algebra to move some stuff around. So let's see how we're going to start this. So let's move this up a little bit. So here, notice that k is underneath this fourth root here. So I want to start by undoing this fourth root. So I'm going to take each side and raise it to the fourth power. So this would look like the first step, y to the fourth is equal to, when I take this fourth root and raise that whole thing to the fourth power, this leaves me with 20k s squared and then divided by w. So now I've gotten rid of this fourth root here. Now all I want to do is try to isolate k. So here there's division by w on the side. So let's multiply both sides by w first. So this would look like y to the fourth times w equals 20k times s squared. Now here, we can think of this 20k s squared as just 20s squared and then multiplied by k. So to just get rid of this k, I need to divide by the 20 times s squared. So if I divide both sides by 20s squared, then the 20 goes away. And the s squared goes away, but I also have to divide over here. So this is divided by 20s squared. And then when I do that, I'm left with k equals y to the fourth times w divided by 20s squared. So now I've solved for k like it asked. So now let's go on to the next one. So this says write 5 times the square root of y divided by 2 plus 8y over y squared as a sum of the form m times y to the q. So we want y to be up here in the numerator. It can also have a negative exponent, but here we want it up in the numerator. So this first one here, we want the coefficient or the constant out in front here. So this would be 5 halves is going to go out front here. So we'd have 5 halves. And then we want to write it as y to some power here. So remember from earlier, here we have the square root of y. Can also be written as y to the 1/2. So this would be 5 halves. Y to the 1/2 would be how I write this first one here in this form. Now I'm going to also add to this. Here I have 8y divided by y squared. But this y over y squared is going to give me an 8 divided by y, right? And then again, here, I have the y in the denominator. If I want to bring it back up to the numerator, I need to negate the exponent. So this would be 8y to the minus 1. So that'd be the other term here. 8 times y to the minus 1. And that's the final form. I want it as a sum of the form m times y to the q power, and I've done that here. So now this next one here is kind of an algebra type problem. So it says during a viral outbreak in the city, officials estimate that the number of people infected t days after the first case were discovered is given by p of t is 30 times t to the 3 halves. So it says at the start of what day will 1,500 people be infected? So this is a value of p of t, right? We want to know what day. So we're solving this expression here when we set it equal to 1,500 for t. So let's do that. So we have 1,500 equals 30 t to the 3 halves power. So we're going to start by dividing both sides by 30. And when I do that, 1,500 divided by 30 gives me 50. So I have 50 equals t to the 3 halves. So how can I undo this part here to solve for t? So let's think this real quick. So when I have something that looks like t to the a over b power, and I want to end up with 1 at the end here, I need to multiply this or raise this whole thing to the b over a power. Because remember, when I raise an exponent to another exponent, these exponents multiply. And a times b, a divided by b times b divided by a is 1. So I would end up getting at the end of here t to the 1, which is just t, right? That's what I want it to be. So here I'm going to take both sides and raise them to the 2/3 power. So then t would be equal to 50, and then raise this to the 2/3 power. And then when you approximate this, so let's grab a calculator real quick and approximate this. So after I approximate this using a calculator, let's say to 2 decimal places, this is 13.57 days. Or you could round it to the nearest day and say this is approximately 14 days. So let's move on to the next question. So this one here says the following graph represents an exponential function. Write the function showing all work. So here, let's look at what the 2 points are on this graph. So here we have the point 3, 7. So here we have the point 3, 7. And here we have the point 0. What is this? 1, 2, 0.4. So 0 and then 0.4. So I have 2 points on this exponential curve, so I can create an equation of this by using these 2 points. So what we're going to do first is remember what an exponential function looks like. An exponential function looks like y equals a times b to the x power, something like this. So what we want to do is use these ordered pairs to kind of write something like this and solve for what's a and what's b. So let's start with this on the first point. So let's say x is 0 and y is 0.4. So this implies that I want to plug these in here, right? That here I would have that 0.4, which is the y coordinate, is equal to a times b to the x, and x is 0. But here, what's b to the 0? B to the 0 is just 1. So this is saying here that I have a times 1 is equal to 0.4, or that a is equal to 0.4. So now I know what a is here. All I need to do is figure out what b is. So let's see how we can do that. So let's use the second point up here. So we have the point x equals 3, y equals 7. So, and I also know from part A, or from this first part here, that a is 0.4. So now I can solve for what is b. So here this would look like 7 equals a is 0.4, and then we have b to the, in this case, 3, because x is 3, so b to the third power. So now what we're going to do is start by dividing both sides by the 0.4. So when I take 7 and divide it by 0.4, I get 17.5. So this says that 17.5 is equal to b cubed. And now to undo the raising to the third power, I need to take the cubed root of both sides. So this would say that b is the cubed root of 17.5. And if I plug this in the calculator and see what this is, 17.5, the cubed root of it. If I go to 2 decimal places, this is 2.60. So this is approximately 2.60. So now I know what a is, I know what b is, I can write the function. So we want it in function notation, so it's going to look like f of x. So we had f of x, because we want it in function notation here, so we have to tell it what the input is and write the appropriate notation, equals a, which is 0.4, times b, which is 2.60, and then to the x power. And that is the corresponding function for that one. All right, so now let's move on to this next question here that deals with compounding interest. So it says, how long will it take for any sum of money to double if invested at 8% compounded quarterly? So if you're given a question like this on the test, I would remind you of what the formula looks like for this. So let's write it this way. Let's say P of t, or not P of t, let's say A of t, because we're talking about amount of money. So we can say A of t is equal to, we want here, P, that'll be the initial amount we invested, times 1 plus R over N to the N times T. So this is the formula that we're talking about when we're talking about compounding periodically. So not continuously, but periodically. We don't actually need this piece over here yet, so we don't need any of this notation. All we need to figure out is the following. So here we have our compounding periodically. So let's see how we're going to use this. So it says if we want to double our investment, so that means that this amount here, which represents our balance in the future, we want it to be equal to 2 times the original amount we invested. So we want this to be double what we originally invested. So here we have on the other side P times the same thing, 1 plus R over N to the N T. So now we can divide both sides by P and make the P's go away. So we're left with 2 equals 1 plus R over N to the N T. So now we actually know a couple of things already, right? We know the interest rate, it's 8%. So this implies that R is 0.08. And also we know how often it compounds quarterly. So compounding quarterly implies that N is 4. So we're going to utilize these two facts and plug them in here. So this implies that 2 is equal to 1 plus 0.08 over 4 to the 4 times t, right? Just plugging everything in there. So now what I want to do is let's take the log of both sides, but first let's simplify this in here. So this inside here, 1 plus 0.08 over 4. 0.08 over 4 is just 0.02. So this is actually just 1.02. So this is actually written as 2 equals 1.02 to the 4t. So now how did we do these problems? We started off by taking the logarithm of both sides. So let's do that first. So when I take the log of both sides, I get log of 2 on this side, on the left. And then I get, whenever I take the log of this, remember, based off the properties of logarithms, this 4t will come out in front of side the logarithm. So it'll say 4t, and then times the logarithm of the base, which is 1.02. So 4t times log of 1.02. And now just to solve for t, I divide both sides by 4 times log of 1.02. So t is equal to log of 2 divided by 4 times log of 1.02. And this is equal to, so if I do this, log of 2 divided by 4 times log of 1.02. This is 8.75 years. And this says round approximately to the nearest hundredth. And remember, the hundredth is the second decimal place. So here, that's why I rounded to 2. So this would be 8.75 years. And that's how you do that one. You need to see when is your original investment going to double. So the future value is going to be equal to 2p. You set it equal to just the given formula for periodic compounding. We were given R and N, so we could plug those in and simplify the inside piece here to 1.02. And then once we have it of this form here, we can just take the logarithm of both sides like we did, use the properties of logarithms to bring the 4t out front, and then divide everything else over that's not the t by itself. And then once we do that, we get 8.75 years. So let's look at this one here. So this one says, a scientist discovers 7 fish in a local pond. 3 years later, he observes 29 fish. Assume the population of the pond can be modeled by an exponential function. Write the function for the fish population, rounding all numbers to 4 decimal places. So this is like the one we had earlier, where we have 7 fish to begin with. So at time 0, there were 7 fish. So this is the ordered pair for this. 0 years, 7 fish. So this is the initial time that he saw the fish. Then 3 years later, he observed 29. So this ordered pair is 3 and then 29, right? So this is like what we did earlier. We want to use an exponential model. So what we're going to do is utilize these two ordered pairs. So remember, an exponential function looks like y equals a times b to the x, right? So we're going to use this idea again. Let's look at the first ordered pair when x is 0 and y is 7. So when we have x is 0, y is 7, then this right here would look like 7 equals a times b to the 0. But again, b to the 0 here is just 1. So this is saying a times 1 over here, which is just a. So we have a is equal to 7. So now we know what a is in here. We just need to solve for what is b. So let's use our second point up here. X is 3, y is 29. So then we have that 29 is equal to a, which was 7, times b to the third. And now we're going to divide both sides by 7, and we get 29 over 7 is equal to b to the third. And again, to undo to the third power, we cube root both sides. So this would be b is the cubed root of 29 over 7. So let's use the calculator to simplify this. So the cubed root of 29 over 7. So how many decimal places does it want? It says 4 decimal places here. So this b to 4 decimal places would be 1.606 and then 1. So now we know what is, we know what b is. Now we can actually write out what this is. So this was 1.606, right? So here we have, if we want to write it back in function notation, remember function notation looks like f of x. So we could say f of x is equal to 7 times 1.6061 to the x power. And that's how we do that one. So let's move on to number 11. It says Nia purchases a battery with an initial charge of 100 units. She learns it loses half its charge every 5 years. So this 5 years is going to come into play in this one. So it says write a function that represents the charge in units after 2 years, and also if the battery costs $48.50, write a function for its value. So we want to use this first part right here, the initial charge of 100 units. So we're going to have a function c of t for the charge, right? So C of t, the initial charge was 100 units or 100 whatever it is, usually units for batteries or volts or amps, something along those lines. And it says it loses half its charge every 5 years. So we're going to have the base here is going to be 1/2 of the exponential. So 1/2. Now we have to think if we're plugging in years here, it's not going to lose half its charge in just 1 year. It's in every 5 years. So to account for this, I'm going to take t and divide it by 5, right? Because think of it this way, whenever t is equal to 5, then I have this is equal to 1/2 to the 1, which is when it actually uses half of its actual charge. So say, for instance, here, whenever we have t is 5, this would be 50. So we had to divide by the 5 because that's whenever it actually has reached its half-life, as in 5 years. So we could use this same idea to talk about the value of the battery. So here, all we're going to do is we would change the corresponding coefficient out front here for the value. So here, what was the cost of the battery? So the cost of the battery was $48.50. So the value of the battery after t years is going to be equal to the initial cost of the battery, $48.50, and then times this same 1/2 to the t over 5. Because if it's lost half of its charge, it's basically lost half of its value. So these ones are a little bit tricky because it says every 5 years. Say, for instance, if it said it loses half its energy in 4 years, this would be a 4 here and a 4 here. If it said it loses it every year, then this would just be t here, and down here would also be t. So let's move on to number 12. This says a population of rare birds decreases by 80% every 12 years. If there are currently 200 birds remaining, model the population Q of n after n 12-year periods. Assume the species becomes endangered when the population drops below 40. So here we want to again write a exponential function for this. So it's going to be Q of n. So remember, the coefficient that goes in front is going to be the initial value, and the initial value is 200, right? So this would be 200. And in this case, be very careful because here we're talking about in 12-year periods. So we don't need to divide by anything here because we're already talking about 12-year periods, and it decreases by 80% every 12-year period. So we don't need to worry about n divided by 12 here like we did on the last one when we had to do t divided by 5 because that t was in years. But here, this n is in 12-year periods, so we're okay. So we just need to figure out what is the base here, right? So if it decreases by 80%, that means it's at 20% of the original population every 12 years. So 20% as a decimal is 0.20. And then we raise this to the n power, right? Because this is in 12-year periods, so we're okay just to raise it to the n power. We don't need to divide by 12 here. So now this says, what is the domain of the function? So domain, what are we thinking of here? So domain is the input. So here we're talking about n, and n is 12-year periods. So n can't be negative, but n can be positive. So the domain here is just all positive numbers, right? So the domain, if we're writing this in interval notation, would be from 0 to infinity, right? We start at 0 when we initially had 200 birds, and then we continue on for the rest of time. What about the range here? So the range is going to be a little bit trickier to find if you don't know how to graph it, but let's think of it this way. This is a what type of thing? An exponential growth or decay? It's a decay. So it's decay because here, this number, the base, is less than 0 and 1. It's in between 0 and 1, so this is going to be a decay. So the largest that it's going to occur, or largest value that the range is actually going to take on, is whenever we plug in n is 0 here. So it's going to be the initial value because every year after that, this is going to continue to go down. So therefore, our largest value for the range is actually going to be 200. And what would be the smallest value? So we can technically never hit 0 because we're still going to have birds in the population. So 0 is going to be our lower limit, and 200 would be our upper limit because the amount of birds we started with. Notice that this 40 did not come into play anywhere in this. So let's go ahead and move on to the next one. So number 13 says Harmony begins studying the population of painted turtles in a lake and models it with the following expression. Is this an exponential growth or decay function? Explain why. So I kind of talked about up here. If the base of your exponential is in between 0 and 1, then it's a decay. If it's greater than 1, it's a growth. So here, the base of the exponential is 1.25, right? So 1.25 is greater than 1, so this implies that this is a exponential growth. Because the base of the exponent was greater than 1. That's what makes it an exponential growth. Let's move on to part B. So part B says, what is the vertical intercept? So I'm going to try to show both of these things so I can look at the equation in the next part. So what is the vertical intercept? So it's talking about the x or the y-intercept, right? So if we're talking about vertical, that's up and down. So this is going to be, what is the y-intercept here? So the y-intercept occurs when we have x is 0 or t is 0. So we'd say n of 0, right? And then we're going to plug in 0. This would be 20 times 1.25 to the 0. So here, anything to the 0 power is 1. So this is just 20 times 1, which is 20, right? And what are our units here? What are we talking about? We're talking about the population of painted turtles, right? Up here. So the units here would be 20 turtles. So it says, what does the growth or decay factor mean in this problem? So let's go back to it. So this is 1.25, right? So if we think of 1.25, it's written as 1 plus 0.25, right? That's another way to write 1.25. So here, what is this saying? This is saying that the population of turtles is going up by 25% each year. The population of turtles increases by 25% each year. And then it says, what is the growth decay rate for the turtle population? So in this case, we're talking about a growth rate, and it's this 0.25 here. And if we convert this back to a percentage, it's 25%. So the growth rate is 25%. Then it says sketch a rough graph of the function. So you could do that if you want, but I really wouldn't expect it on a test, especially since most of your homework, it was mainly just pick which one if there was any on the homework. So if you wanted to, you could just draw something like this on the test if I asked. So here you just have the vertical intercept is at 20. So let's say we start here at 20. So here is 20. Here is t. Here is n of t. And this is just a growth, so you can just draw it going up. And that would be okay. That would be okay for the test. If you're just trying to sketch a rough graph, tell me what the vertical or the y-intercept is here, and just draw an exponential curve that goes up. That would be okay. And for part F here, what does it say? What is the turtle population 4 years after the study began? Round to the nearest whole number and show work. So here we're talking about plugging in 4. So this would be n of 4. So plugging in that, I have 20, and then times 1.25 to the fourth power. So let's see what I do when I get that. 20 times 1.25 to the fourth power. So this is 44.83 when I round to two decimal places at first, so 48.83. But it says round to the nearest whole number here. So this is actually going to be, I'm going to round this up to 49 turtles, right? So now let's go on to part G of this question. There's a lot of parts to this one. So this gets you good practice with types of things you could see on the test. So if you can go through a problem like this, you could do a couple of different things. So this last part says, in what year will the turtle population reach 120? So this is saying, when will n of t equal 120? So we need to set 120 equal to 20 times 1.25 to the t. And first, we're going to divide both sides by 20. So when we do that, 120 divided by 20 is 6. So this would say 6 equals 1.25 to the t. Now we're going to take the log of both sides. And when we take the log of both sides, this t is going to drop out in front. So this would say log of 6 is equal to t times log of 1.25. And now, to solve for t, I just divide both sides by log of 1.25. So t is log of 6 divided by log of 1.25. So let's see what this ends up being. So plugging this into the calculator, log of 6 divided by log of 1.25. This is 8.03 years. So it didn't specify how many decimal places here. So I'm just going to go to 2. So I'll say 8.03 years. All right. So that is all for question number 13. Let's move on to number 14. So number 14 says rewrite 5 to the 2.7 equals k in logarithmic form. So remember this idea of circle of logarithms that we talked about in class. So if we have a to the b equals x, this is equivalent to log base a of x equals b. So we're just doing a circle. Log base a of x equals b. So let's do that idea here. So this would be log base 5 of k is 2.7. So let's do this. Log base 5 of k is equal to 2.7. And we don't need to solve or anything here. All we needed to do was just convert this from exponential form into logarithmic form, and that's what we did here. So number 15 says combine 2 times log of 3w plus 5 times log of q plus 1 into a single logarithm. So let's go ahead and do this first. So what I'm going to do is here I have coefficients out in front of each of these. So what we're going to do is actually bring these coefficients back into an exponent inside the logarithm. So this would look like this. I would start with log of 3w, and I would bring this 2 back into the exponent of the logarithm right there. And the same thing here. I would do plus log of q plus 1, and I'd bring the 5 back into the exponent up here. Now, what we can do is if you want, you can rewrite what this is. This is 9w squared right here. So this is 9w squared. I'm just going to note that right here. So now we're going to use the idea that when I'm adding two logarithms that have the same base, it's like multiplying these inside pieces here. So this would be like saying log of this piece inside here, which is 9w squared, and then times this piece inside the logarithm, times q plus 1 to the 5th. And that's the simplest we can get on that one. So this was combining a sum of two logarithms with coefficients into a single logarithm. This next one wants to actually expand this logarithm. So what we're going to do first is do this division piece here. So whenever we're dividing two things in a logarithm, remember it goes into the subtraction of the two. So this would be log of x squared y times the square root of c, and then minus log of x plus y. So let's see how we can try to expand this. So we've done the first part where we do the subtraction. Here what we can do is we're multiplying three things inside this logarithm. So what we can do is expand this portion here. So let's do this. This would be equal to log of x squared. So think of it this way. If I had log of a times b, remember this is log of a plus log of b. What if I take c and I also put in here? So think of it like this, log of a, b, c is equal to log of a plus log of b plus log of c. We just, again, add on that last piece. So we're going to use that idea here. So this would be log of x squared plus, so let's kind of put a little box around this to keep this out of the way of what I'm actually doing in this problem. So this would be log of x squared, the first piece, plus log of y, the second piece, and then plus log of c, the square root of c. But remember, we can write the square root of c as c to the 1/2 power. So we're going to say plus log of c to the 1/2, and then we have minus log of x plus y. So now the last step here is here we have exponents inside these two logarithms. Let's bring those exponents out front. So this would be equal to 2 log of x plus log of y then plus 1/2 log of c, and then minus log of x plus y. And this is the final expanded form we have here. So that one took a little bit more time because here we had three different things being multiplied in the numerator. So we could expand it into the sum of the three logarithms of each of those pieces. Then we could use the exponential rule of logarithms to bring the exponents out in front inside of the logarithms. So that's the final answer to number 16. Now let's look at number 17. So solve the equation exactly for k using logarithms. So here I want to start by subtracting 2 from both sides. So subtract 2, subtract 2. Or not 5, not 2, 5. Sorry, I looked at this 2 and thought 2 in my head. So we're going to subtract 5 from both sides. So when I do that and subtract 5 from both sides, this would say 2 to the k is equal to, here we have 8. So you can use the circle of logarithms to do this if you want. So if you wanted to do that, this would say log base 2 of 8 is k. So log base 2 of 8 equals k. So if you plug log base 2 of 8 into your calculator, it's actually 3. So this implies that k is 3. Or you can think of it this way, 2 to what power is equal to 8? So if we do 2 times 2, that is 4. And then when I multiply by another 2, that's 8. So this is 2 to the third power, so k would be 3. So let's look at number 18 here. This says the following graph represents the function P of H, the atmospheric pressure in atmospheres, given the height above sea level. So here, this is in 1,000 meters. So let's keep that in mind. It says estimate P of 2 and explain what it means in the context of the problem. So here, P of 2. So this is a input of 2. What is the output that corresponds to it? So we're going to say this is roughly equal to 0.8 on this axis over here, and this axis is atmospheres. So here, and this height is in thousands of meters. So our estimate of P of 2 would be, I'll say P of 2 is approximately, based on this graph, 0.8 atmospheres, ATMs. So it says, what does this mean in the context of the problem? So here, what is this talking about? P of H is the atmospheric pressure given the height above sea level. So here, this is in thousands of meters. So this 2 here is actually saying 2,000 meters. So we could say that 2,000 meters above sea level the atmospheric pressure is, here it is, 0.80 atmospheres. So it's 0.80 ATMs. That would be how you interpret that one there. So that's part A. Given a value of the input, what is the output? Let's look at this next one here, where it says estimate P inverse of 0.60 and explain what it means in the context of the problem. So here, this 0.60 is actually representing the pressure in atmospheres, right? Because this is P inverse. So this inverse function takes in the output of my original function. The output of my original function, P, was the atmospheric pressure, right? So what I'm going to do to find P inverse of 0.6 is going to go onto this graph here, go where P of H is 0.6, and go over to the value of X. So if I go over here, this happens at right around 4, right? So here, this P inverse of 0.60 is actually equal to, here, this is 4 based off of our scale here, but this is in thousands of meters. So we'd say 4, you could say 1,000 meters if you want, like writing it out like this. above sea level. Or you could just say 4, and then write it out as 1,000, 4,000 meters above sea level. So how do we interpret this? So you could say the atmospheric pressure is 0.60 ATMs at 4,000 meters above sea level. Sorry if you're hearing my girlfriend in the background. She's messing with the dogs. She has been for a while. So now, this idea of inverses here. Given a graph, when we're dealing with inverses, you're going to go to the corresponding output axis, figure out what the input is here. So this one here gives us a formula. We actually want to find what the inverse is. So remember, there are some steps we had to do. So let's start with step 1 of finding the inverse. So step 1 was replace whatever this f of x, g of x, whatever it is with y. So we're going to say y equals 3 plus, oops, sorry, that was a bad 3. Let's say 3 plus 12 over x. Now my step 2 was swap x and y. So I'm going to do step 2 just over here so I have enough space on the paper. So step 2 was interchange x and y. So this would say x equals 3 plus 12 over y. Now my third step is to solve for y. So I want to solve for this piece here. So I'm going to start this by, so I want to look at this term finally. So let's subtract 3 from both sides first. So this would say x minus 3 equals 12 over y. Now I've done this trick a couple of times in class where I just flip both sides, right? So let's try to do that. So if I try to flip both sides, this x minus 3, when I flip it, becomes 1 over x minus 3. And whenever I flip 12 over y, it becomes y over 12, right? And now to solve for y, I just multiply both sides by 12. And then I would have that y is equal to 12 divided by x minus 3. So now I've solved for y in my third step. Now my fourth step was to rewrite this using inverse notation, right? Inverse function notation. So step 4. So here I replace this y with g inverse of x. So this would say g inverse of x is equal to 12 divided by x minus 3. So that's how I find the inverse. First step, replace f of x or g of x with y. So here I have y is 3 plus 12 over x. Then I interchange the locations of x and y. Then I resolve my equation for y in step 3. So here I notice this term involved y. So I moved everything else over. So I subtracted the 3. Then here I saw that y is in the denominator. I want it to be in the numerator. So I flipped both sides. And then once I flip both sides, I can multiply both sides by 12 to solve for y. And then I replace y with g inverse of x. And that is my completed inverse here for number 19. All right, for this last question here, it says match each graph with the graph of its inverse. So this one is kind of hard to see, but what I'm going to do is utilize this idea that if I have an ordered pair on my original graph AB, so if my ordered pair on my original graph is AB, then the graph or the pair on the inverse graph will be BA. All that happens is the coordinate swap spot. So I'm going to look at a coordinate on this graph here, or a couple of them, and then see which one has the opposite on these graphs over here. So let's look here at 1, 2, -3, -2. So I'm looking at this point here, -3, -2. So I need to look at and see what graph over here has the point -2, -3. So here, this first one does not have the point -2, -3. Does this one? 1, 2, 1, 2, 3. This one does not either. Let's go right here. -2, -3. No. 1, 2, 1, 2, 3. This one here has the point -2, -3. So then A goes with graph 4. So A and 4 are inverses, these two right here. So let's go to this next one here. I'm going to do the same thing, pick an ordered pair on here, see which one has it on the inverses. So here, I've already used 4. So we're not going to use that again. So let's look here. This one has an ordered pair of 2, 1 on the original graph. So 2, 1. So my inverse function is going to have an ordered pair of 1, 2, right? So let's see which one has this. This one here does not have 1, 2. This one does have 1, 2 right here. So this implies that the inverse of B is the second one, number 2. So now we've used up 2 and 4. Now let's look at these other two right here. So this one here has an ordered pair of -1, -2. So this one is -1, -2. So when I flip that, the corresponding ordered pair would be -2, -1. So when I look over here, -2, -1, it's this graph up here, number 1. So that means that C has inverse graph 1, and then here the only option left for D is for 3. So D is going to go to 3. But let's verify it. So if I look at an ordered pair here, we could say -2, -1 is one of them here. So -2, -1. So the inverse must have the point -1, -2. So here, you can't actually see it on this one, but let's continue on and try another point. Say, for instance, we look at the point 2, 1. So if I look at the point 2, 1, which is right here, this point 2, 1, this graph up here actually has the point 1, 2. So 1, 2 is on this one here. So then we do have that this point here, 2, 1, does correspond to a point 1, 2 on this graph 3. So here we have our inverse graphs for the ordered pairs. So A has inverse graph 4, B has inverse graph 2, C has inverse graph 1, and D has inverse graph 3. And those are all of the questions that I put on the practice test. So make sure you can work through these questions. Try to do them on your own before you actually watch the entire video. And then just make sure you can go back through, work them on your own. The test will be the entire hour and 15 minutes of class. And I'll let you use the TI-84 calculator on the test if y'all have that, just because it's a little bit easier to plug things into. And if y'all do have any questions on how to plug something into the calculator, the basic one that was required for the course during the test, just ask me that way. Y'all don't give me any wrong answers on the test since there was an issue on the last quiz. That is all I have for y'all. Y'all have a good one.